I decided to do short video tutorials depending on for each subject or for each chapter. So I am going to start my first video tutorial. It's not going to be more than 3-4 minutes long. Maximum would be 5 minutes. Okay. So I'm going to go over our first units. That's our first chapter. And then a little bit on kinematic equations. I think this is going to be helpful because all the ensemble anthem videos are at this point not functional. All right, so I'm going to share my camera. I think for that I have to remove my background. Okay. So I believe that you can see this. So the first video tutorial, it's going to be on units. And something that I see among students that they just always forget, or most of the time they forget to include the units. So here I'm going to go over the SI units first. And the lecture actually will detail everything better. And there are 3 SI units. For length, we are using meters. For time, it is going to be seconds. And then for mass, it's going to be in kilograms. So you will learn that some commonly used, quantities velocities, accelerations, and those type of things. I'm going to give you the commonly used units in our lecture. So velocity is given in meter per second, acceleration in meter per second square, and meter per second square. And then force, the human scale that we are using in the class, that would be Newton. And energy, we will be using Joule. So Newton and Joule, they are actually called as human scales. So basically, to honor the scientist, we are using these scales. Let me remove the lamp a little bit away. So this is what we have. So it is really important that we use unit conversions when we are doing a problem. So sometimes for this class, the units are given in non-SI scales. For example, force would be given in pounds. And then the velocity or the speed will be given in kilometer per hour or mile per hour. So I'm going to do a quick example and just show how to use the DA table. First of all, I am going to give you some unit conversions. So let's say the relationship between meter and kilometer. So meter, 1000 meters equals to 1 kilometer, and 100 centimeters equal to 1 meter, and 1000 millimeter, that equals to 1 meter. So likewise, if you have 1000 grams, now gram is not the SI unit, 1000 gram is 1 kilogram. And then we have milligram, micro, and other units. So let's not worry about those for now. And then about time, let's talk about time. And the time can be given in hours. And 1 hour would be 3600 seconds. I directly converted that into seconds because a second is the SI unit for time. And if something is given in, let's say, minutes, so 1 minute would be 60 seconds. So if you have, I'm actually going to use this as 1 minute, and 1 minute would be 60 seconds, and we can do the conversions accordingly. Now let's say that we want to convert something like I'm just taking an example. 5 kilometers. We want to convert 5 kilometers into meters. So this is just showing how to use the DA table. DA stands for dimension analysis. So what you do here is you write 5 kilometer and you set up the table, and you want to cancel kilometers and kilometers and end up in meters. So we check what the relationship between kilometers and meters, and here you can see 1 kilometer equals to 1000 meters. So here's how you use the DA table. I know some students in the class have not used this, and that's why I am using it, so that everybody can see this. After that, you multiply the two, and there you have 5000 meters. And that's the answer in meters. So let's do something little harder. And let's say we have a velocity given as 20 kilometer per hour. 20 kilometer per hour. So just the same way, we use the dimension analysis table, and here's how you do it. So 20 and kilometer, you leave it there, draw the table, and you place this hour in here. So it's basically you have 1 hour in here, and if you use parentheses here, you can call this as 1 kilometer. So like last time, we want to cancel the kilometer, and we can use the same conversion as before. So you have 1 kilometer equals to 1000 meters. Then we are all set with that unit, because you can cancel the kilometer and kilometer out. But we have 1 hour left in the denominator. Now we go back and check where we have the unit conversion for hour to second. So 1 hour equals to 3600 seconds, right? So 1 hour is in the denominator. So we are going to have the hour in the numerator so that we can cancel those two out. But the equivalence of 1 hour is 3600 seconds over here. So you can cancel the hour and the hour over here, and you can cancel the 2 zeros from this, just a regular division, and there you have 20 times 10 meter, and then divide it by 36. So I don't have the calculator right next to me, but that would be 200 divided by 30 seconds. Okay, I forgot the seconds here, because you have the second here. And then the final answer will be given in meter per second. As we discussed earlier, meter per second is the SI unit for velocity. So we will use this method many times over the semester, and I believe you understand what we just did. So I don't want to make this video too long, so I'm gonna stop it here, and I'm going to save it and create a YouTube video and post it under announcements. Excuse me, under announcements on Blackboard. So each week you will see a short video clip like this under announcements. Okay.